Here we go, we're getting into lesson 11. In lesson 11, we're continuing to investigate exactly what area means and really check it out in a very hands-in way in lesson 11. It's going to be pretty cool. We're going to be using paper tiles and we're going to be trying to figure out the area of a few different rectangles using these paper tiles. So all along the way we're going to continue using this partial product modeling as we get closer to the traditional algorithm. We are going to continue multiplying we are multiplying mixed numbers, but we're not using the traditional algorithm yet. I really love this investigation with the tiling and with the partial products within our modeling, just because it really gives you a very solid foundation, very solid understanding of what area really means, area of a rectangle really means, and then also what we need to go through in order to multiply mixed numbers. It's not just a mindless calculation. We have to be very thoughtful when we're multiplying these mixed numbers. So we're going to check out a few examples here, and then like I said, in class tomorrow you guys are going to be getting your hands on some actual paper tiles, and you're going to be finding the areas of a few different rectangles. Here we go. Okay, kiddos, here we go. We are going to check out some rectangles. Right now, we're going to be given some dimensions, and then in class tomorrow, you're going to be given a rectangle, like I said in our intro, and you're going to be then further investigating its area. So we are responsible for drawing these rectangles. Please keep in mind that I am not concerned about these rectangles being completely perfectly proportional. I'm just going to focus on drawing a straight line. Okay, so we have a rectangle. Here it is. We have some dimensions that we've been given. It's 2.5 units long by 3/4 wide. So what we're going to do is we're going to decompose 2.5 to 2 and 1/2. 2.5, of course, is our mixed number, meaning it's mixed up with, it's partially made up of a whole number and partially made up of a fraction. So we are going to decompose 2.5, like I said, to 2, and then we're going to label this 2 and 1/2. So our length is composed of 2 parts. Why did I draw a 4th? That was funny. I meant to draw a 1/2. So I'm still getting used to this new program. I must tell you, it's pretty awesome because it actually is sensitive to the type of touch that I'm giving the pad. So that's a light touch, and then if I push down harder, it's darker. So it's pretty cool. I must say that I'm into this new program. So we decompose 2.5 to 2 and 1/2, and so that's the length. And now we're going to look at the width. The width is 3/4. Last week when we were working on lesson 10, we were decomposing 3/4 into 1, 2, 3/4, but now we're just going to keep it as 3/4. So we've set up our rectangle here, and now we're going to be doing some multiplying. We're going to think about the area inside this rectangle and the area inside this rectangle. So in order to figure out the area inside this rectangle, we're just going to multiply the length times the width, or 2 times 3/4. Okay, so this rectangle, the area is going to be found within 2 times 3/4. And now let's check out the area of this rectangle. The length of this rectangle is 1/2. And the width of this rectangle is 3/4. So in order to find the area, we're going to multiply 1/2 by 3/4 for this rectangle. Okay, so now let's do some multiplication. 2 times 3/4, well, all we have to do is multiply upstairs. 2 times 3 is 6. And then downstairs we have 6/4. Okay, I'm sorry, downstairs we have 4. 2 times 3/4 is 6/4. We're going to leave this as an improper fraction for now. In the end, we will simplify. Let's see what's going on inside this rectangle. So we have 1/2 times 3/4. We'll multiply the tops first. 1 times 3 is 3. And then 2 times 4 is 8. So I'm sorry, I'm not labeling my units. Bad, Mrs. C. The area of this rectangle here, the larger one, is 6/4 units squared. The area of this secondary rectangle is 3/8 units squared. So what we have here are 2 partial products, or 2 areas. in order to find out the area, let's switch colors. In order to find the area of this entire rectangle that I'm outlining right now in red, we just need to simply add our two partial products. We just need to add 6/4 with 3/8. That will give us the area of our entire rectangle. 4 and 8 do not have a common denominator. We need to transfer something in to a denominator that is the same. So let's think. 4, 8, 4, 8. We're analyzing these numbers in our head. We're thinking about, can I multiply one number by another? Can I multiply 8 by anything to make it a 4? Can I multiply 4 by anything to make it an 8? Hopefully by this time in my silly chatter, you've realized that, oh, I can multiply 4 by 2 to make the denominator 8. And if you're going to do that on the bottom, you better do that on the top, because you know numerators and denominators are really jealous of one another. So let's go ahead and transfer 6/4 into a new equivalent fraction. That equivalent fraction, of course, means equal. That has a common denominator of 8. So 4 times 2 is 8, of course. 6 times 2 is 12. So now we've found that 6/4 is equal to 12/8, because all we did here, friends, is just multiply 6/4 by a fancy version of 1. That fancy version is 2/2. The reason why we did that is so that we can transfer our denominator into 8. So that worked out perfectly. Now let's think about 12/8 plus 3/8. 12/8 plus 3/8 is 15/8. Improper fraction alert. Let's think about, well, first of all, the fact that the numerator is larger than the denominator. That is an improper fraction. How many whole numbers can we pull out of 15/8? Well, we know 8/8 is equal to 1. So I know that we can pull out 8/8. We can pull out a whole number from 15/8. So we can rename 15/8 as 1, and, well, when we pulled out 8/8 from 15/8, we were left with 7/8, because 15 minus 8 is 7. And that is as simple as we are going to get here. 1 and 7/8 is the area of that fancy rectangle. So it's 1 and 7/8. And Eureka was so kind, thank you, Eureka, to go ahead and label our units for us. In the directions, which I actually cut out, we are asked to go ahead and model this rectangle to find the area. And then we also need to use the distributive property and sort of back up our work with some very simple multiplication. So what we ended up doing here was 2 1/2 times 3/4. So we're just going to look at that a little bit more closely and sort of check our work with the modeling using some multiplication, and let's keep our fingers crossed that we are going to end up with the same answer. So we're going to look at 3/4. So we're given the dimensions. We're going to look at 3/4 times 2 1/2. 3/4 times 2 1/2 is the same as 2 1/2 times 3/4. It does not matter which way we multiply that. Let's use the distributive property and think about what this means as far as our mixed number multiplication goes. 3/4 times 2 1/2 is equal to 3/4 times 2. We did that over here, 3/4 times 2. It's a partial product, so we're actually going to add that first product with 3/4 times 1/2. So when we're multiplying these mixed numbers, we have to decompose them. So we have 3/4 times 2, okay, and then we have 3/4 times 1/2. I have both of those multiplication expressions in parentheses, and since these will result in a partial product, we're going to add those partial products together to hopefully get our final product. So let's see what happens here. Well, 3/4 times 2, upstairs we have 6, downstairs we just have 4. So 3/4 times 2 is 6/4. And then over here we have 3/4 times 1/2. That's going to be, and I know I'm speaking really quickly here, you guys, we have a lot of ground to cover and I don't want to make this a 45-minute video. So if I've gone too quickly, please remember that you're in charge of your learning. You need to pause and rewind if you've missed something along the way. Please remember that you are in charge of your own learning and you need to pause and think about something if it seems a little hazy, or even rewind. Sometimes hearing and seeing the same thing twice will make more sense in your brain. So think about where you are right now and your understanding. This stuff that we're doing right here is review. So if you're feeling a little forgetful as to how we multiply whole numbers and fractions, pause or rewind and watch. Okay, so we have 3/4 times 1/2, so that's 3/8. So what we're dealing with here is 6/4 plus 3/8. We had the exact same expression up here. You guys are immediately realizing, oh, 4 and 8, we don't have a common denominator. Well, that's okay. We don't have a common denominator yet. I can find an equivalent fraction to 6/4 just by multiplying 4 by 2. We get an 8, and we know if we're going to multiply 4 by 2, we have to multiply 6 by 2. That will result in a 12. So, oh, this is really good news. We have the same expression here next door. 12/8 plus 3/8 is going to be equal to 15/8. When we simplify that, we are going to get 1 7/8, and that is exactly what we got here on the left-hand side with our modeling. Fabulous, fabulous. We're going to take a look at another one, guys. Okay, kiddos, so we are going to continue here in lesson 11. We're going to look at letter C, where we're going to use that tiling method to find partial products of two mixed numbers, and then we're going to arrive at a final area. So let's take a look at this. So we have another rectangle. This is rectangle C. We are given the dimensions that are going to be 3 1/3 units long by 2 1/2 units wide. So again, we are going to draw that rectangle. I'm going to leave a little bit more room. I'm going to work on a nice straight line. I'm almost there. Again, this rectangle is not proportional. Wow, that is something extra special there, Mrs. Calamares. You know what, we're just going to go ahead and try that again. We are going to be decomposing both of these mixed numbers. So I want to make sure that I have plenty of room inside my rectangle. So this rectangle, as Eureka has given us our dimensions, is 3 1/3 units wide. And I'm sorry, 3 1/3 units long, and then it is 2 1/2 units wide. I'm going to go ahead and decompose this right away just because I don't have too much room. I'm going to decompose this part of the rectangle to 2 1/2. The mixed number, 2 1/2, is made up of 2 wholes and 1/2. So I'm going to go ahead and decompose that here as 2 1/2. We're going to do the same with 3 1/3. I just did not have enough room here on my left margin. So let's go ahead and decompose 3 1/3 to our whole numbers and our fraction. 3 1/3 consists of 3 wholes and 1/3. Okay, so we have our rectangle. It's 3 1/3 units long and it's 2 1/2 wide or 2 1/2 tall. We're going to use our partial products and multiply these pieces together, and then we're going to end up with 1, 2, 3, 4 partial products. So let's go ahead and go. I'm going to use a different color for each so we can see our 4 separate partial products. So for this rectangle right here, still working on writing a little bit harder with this pen and my new application here. So we have 2 times 3. Boom. Awesome. 2 times 3 last time I checked, thank you, Kendi, is 6. So that's our first partial product. Now we're going to move to the right for our second partial product. Our second partial product is going to give the area of this rectangle that I am outlining in green. So our second partial product is going to be made up of 2. It's 2 units tall and 1/3 wide. 1/3 units wide. That's 2 times 1/3. Sorry, I'm going out of the rectangle here. 2 times 1/3 is simply 2 2/3. Sorry, that's getting a little messy. It's 2/3. Okay, so now let's move down. Now we're going to look at this rectangle. This is our third partial product. Whoa, I'm getting a little wild here. I'm trying to outline this third rectangle, and my pen is getting the best of me. Okay, so the expression that we're going to find within this rectangle, as far as what the area is going to look like, is 1/2 times 3. This rectangle is 1/2 tall, or 1/2 wide, and it's 3 units long. So we can find the area by multiplying 1/2 by 3. Very simply, 1/2 times 3 is going to be 3 halves. Again, if I'm talking too quickly, or if you don't understand how in the world 1/2 times 3 is 3 halves, please rewind or just pause and do the work yourself. Let's keep on moving. I'm gonna choose a nice golden orange for our final rectangle, which is right here. Ooh, that's not a very nice orange. No offense, orange. So I'm looking at this final rectangle here. My lines are getting more wobbly and wobbly. I'm just gonna move my work over here to the side. In order to find the area of this rectangle, we're going to look at 1/2 times 1/3. 1/2 times 1/3 is going to give us the area for the orange rectangle. 1/2 times 1/3 is 1/6. So now what we have is 1, 2, 3, 4 partial products. We don't have a full product yet. We have 4 partial products. In order to determine the product of this, the area of this rectangle, we're going to need to add these 4 partial products together. So let's do that. We have 6 plus 2/3 plus 3 halves plus 1/6. So we are adding these up. So we are going to need a common denominator, which we are not quite there yet. We have 2/3, 3 halves, and 1/6. We know that we can multiply 3 and 2 by something and turn those denominators into 6. So let's go ahead and find equivalent fractions for 2/3 and 3 halves. And let's make sure those denominators are 6. Because we have 1/6 here, and then once we transform 2/3 and 3 halves into equivalent fractions that have denominators of 6, we'll be able to just add those fractions together. So what can I multiply 3 by in order to find a product of 6? Well, I can multiply 3 by 2 to get 6, which means I need to multiply 2 by 2. That is 4. What can we multiply 2 by that will arrive at a product of 6? Well, we can multiply 2 by 3. That gives us 6. So that means we need to multiply 3 by 3. 3 times 3 is 9. Okay, so now we have 4 6 and 9 6. And we're going to add that together with 1/6. So now we have 4 partial products. We have all common denominators. We have the same denominator here for our fractions, so that's really helpful. Let's go ahead and add these together. So our whole number right now, that what we're working with, is 6. 4 plus 9 plus 1. Okay, well, I know 9 plus 1 is 10. 10 plus 4 is 14. So what we're looking at is 6 plus 14/6. Improper fraction alert. Our numerator is larger than the denominator. We know that we can pull a whole number out of this fraction. This denominator is 6. So we know that we can pull 6/6 out of 14 and trade it in for a whole number 1. So let's go ahead and rename that and see what we're dealing with. So we have 6 plus 1. We took 6/6 out of 14/6. 14 minus 6. Let's figure out how many 6ths we are going to be left with. 14 minus 6 is 8. 14 minus 6 is 8. So we are going to have 6 plus 1 plus 8/6. Let's go ahead and simplify this again. 6 plus 1 is 7. Another form of 8/6 is, we can go ahead and say improper fraction alert. 8, 6 is an improper fraction because the numerator is larger than the denominator. Let's pull another whole number out of 8, 6. Let's pull another 6, 6 out of 8, 6. And cash it in for a whole number 1. Okay. We pulled 6, 6 out of 8, 6. And now 8, 6 is no longer 8, 6. It is 2, 6. So now we've cashed in 6, 6 for a whole number 1, and what we're left with is 2, 6. When we simplify 7 plus 1 plus 2, 6, sorry, I'm running out of room, we are going to have 8 and 2, 6 left. We can further simplify this as 8 and 1/3. But that is a wonderful, wonderful work. We had 4 partial products. We did some amazing simplification when we were dealing with a whopper of an improper fraction. We are going to continue this good work tomorrow. We're going to do some hands-on learning with paper tiles. It's going to be great. Speaking of great, our secret word of the day is hot. You guys can understand why. Can't wait to see you guys tomorrow. It's going to be a great day in Mathland. See you then.